Hello, everyone. We are very happy that you are here. My name is Jonathan. I'm representing Fine over here together with Dan, our CTO. Today we have a very interesting session. We will start with a talk about Software 3.0 and the future of software development. Where are we headed in a world where AI agents are taking more and more responsibility? And how will development look like in the upcoming years? What should we expect and how can we prepare for it? And following this talk, we will have a short Q&A session with Dan and I. So feel free to save your questions to that time, and we will respond to that. During the talk, I will be able to respond in the chat, but Dan will guide the talk. After the Q&A session, we will get to actually see this new future actually these days where we can already experiment with it. So it's going to be very, very interesting, and I hope you will enjoy it as well as us. I invite you after the talk. I will say a few words, but for now, Dan, you can take it from here.
Thank you, Jonathan, and thank you all for joining. So let me just share my screen. Okay, so thank you, Jonathan, for the introduction. Today, I want to talk to you about Software 3.0 and how we're going to build software in the era where AI takes the lead. So, my name is Dan. I'm the CTO at Fine. If you are not familiar with Fine, we are building the software development environment for the AI era, where software engineers build software with AI agents. But before we dive into Software 3.0 and what it means, we're gonna cover some topics like Software 3.0, the philosophy and the workflow, what are AI agents, and how we can use them in the real life. And maybe provide some real life examples. But before we dive into that, I want to share with you an anecdote about Fine. We actually started as a web series 2 years ago. Jonathan and we started the company. We didn't know that we're going to start the company at that time, but we started as a web series. We called it Dark Mode. We always love tech, and we wanted to explore and learn more about software development. So we made a web series about software development, about software developers, where we interviewed 30 or 40 engineering leaders from companies like Wix and Taboola and AppsFlyer about software engineering and about their challenges. And after we made the series, we transcribed the interview, and we labeled 81 problems in software engineering. And many of those issues that we labeled were about mostly cognitive load, about getting into the flow and context switching and the stress of figuring out the details. And this is where ChatGPT was introduced to the world, and we immediately knew that it's going to change how we build software, and we knew that it has the potential to solve many of those 81 problems that we labeled during our research. So this is how we started, and let's jump into Software 3.0. But before we do that, let's start by saying that we still have a job. The world apparently still needs software, because the world is using software to solve real-life problems. And as long as the world has real-life problems, probably we still need to build software, and software engineers are the best candidates to do so. So we still have a job, thankfully, and because we still need to solve problems. However, the profession is transforming entirely. The way we build software is transforming completely, and we already feel it. And I hope to share with you also my personal experience in the last few months building software with AI. And the reason that the software, the way we build software is changing is simple. AI and machine write code way more faster than humans. Even if we are the best developers, the best coders out there, AI still writes code a lot faster than us. And that means that software development must change. And it also means if software development is going to change in the near future, it also means that the workflow is going to change, and the tools and even the entire environment is going to change, and it is actually changing as we speak. Well, actually, let's take a closer look at this. So, in the old days, in the what we call software 2.0 days, building software was mostly writing code. I know there are developers that would argue differently, and I agree. But the majority of our day was around coding. We were even called coders, programmers, names like this. The majority of our work was to write code, and then we also had to do some code review or even write specifications depending on our personal preferences. In the software 3.0 era, we see a paradigm shift, and it's almost the other way around. Nowadays, as developers, most of our day is, or should be, mostly around guiding the machine on how to build software. It should be mostly about how we guide the AI agent or the AI to write the code for us. And then, of course, we also need to do some code review, a lot more than we had before. And at the end, we still need to write some code because it's not perfect yet. So this is the software 3.0 versus software 2.0 as we see. But one thing that I see that is similar between the two paradigms is that the core skill of software engineers remain the same. In the two approaches, the main thing remains. Our job as software engineers is to be able to identify and analyze and solve real-life problems. And that's still our main job, whether we do it by writing code or by writing plain English to guide other machines to build a program for us. So that's at the high level. Now let's discuss how the workflow, how this integrates to our real-life workflow. So before we dive into the specifics, let's discuss the AI agents. If AI agents are going to be the machine that builds, that writes code for us, let's first understand what it does. So AI agent is just an LLM setup that runs iteratively with some goal or a task defined. It's not a new concept. You can think of it as I think of it as an automation, a script with AI vitamin. It's just a smart script. It has some tools. It can access information, and it can do stuff in the real world. So it has the power of AI, and it also has access to your file system. So it can edit files and commit code to GitHub or something. We're already working with Google Bard or ChatGPT or Claude or whatever LLM that you find useful. But the way we're working with it is like back and forth with the chat. So it's us, and then the chat, and then it's us again, then the chat. And there is that back and forth that even with some plugins or other extensions, it's still very tedious. With AI agents, we sort of hand off the assignment to the AI directly to the LLM, and then it takes over and run a series of steps and workflows before it reports back to us. So less cognitive load and more automation. And the way we at Fine we like to think of AI agents is an entity that has an identity. For example, an agent could be a Python agent that has some skills and has some context. For example, it has the framework, let's say Django or Fast API framework documentation. So it's an agent with identity and that has some specific context. And usually agents will have they will be designed to solve a certain kind of task, or they will be designed to specialize in a specific area or skill. And you could also connect tools to AI agents, like they could browse the repository, they could maybe connect to monitoring service and read some DevOps logs and do actions in the real world. Now that we have an AI agent, we can use them in the real world. So the new workflow, at least the one that we practice in Fine, looks about that. So every assignment in software engineering starts with specifications. That might be the most important part when we build software with AI agents. The more the specs are clarified and have the context for the assignment, the better the AI agent will perform. So we start by taking the specifications from the business requirements, the one that we usually get from the product. And then we break them down into technical specifications, and we provide as much as context that we can to the AI agent. And then once we have the specs, we hand it off to the AI agent, which again will be a dedicated AI agent that best fits for this task. If it's a front-end assignment, then I will assign it to the front-end engineer. If it's a back-end assignment, I will assign it to the back-end engineer, and it can even be more specific than that. It could be an agent that specializes in a specific part of my backend, or it could be an agent that specializes specifically in doing layouting assignments in the front end. So I assign the specs for the agent, and I can even assign it for multiple agents. And then once the agent is finished, I review the code and I provide feedback, and I make some more revisions until I take it from the agent back to my control and do the last mile. So that's the high-level workflow of AI agents in software development. And the workflow of each specific agent could be different from company to company, from team to team, based on the use case and the technology and the project. For example, we can have an agent, a workflow for an agent could look something like this. You guide the agent to first write the test, and then the agent writes the test and write the code that compatible with this test, and runs the code, fix the code until the test pass, and then the agent is finished, and that's our cue that the agent is finished, and we can pick up the work from them. So we all practice test-driven development, but I think that with AI agents, possibly test-driven development is mainly development. And I think that in this world, where we see that the workflow has changed completely, or at least is changing, there is a room to ask if the IDE, the one that we use for the last 50 years to build software, if it's still relevant, or what's the role of the IDE in this era. I don't know if the IDE will still continue to develop using the IDE. I'm sure that we will have some environment to build software, because we still need to build software, but I think that the IDE will no longer exist as we know it, where the main thing, it doesn't make sense that the main thing will be the code, at least speaking in terms of UX. And there are many other ways to integrate AI agents to your workflow today. I think that when I usually deliver this talk, people say that, yeah, but it's like I get the idea, but AI agents is like, it's an interesting idea, but it's not there yet. And my hope is that what you take from this session today is that AI in software development, at least, it's a real thing, and we already use it, and we should use it to make our flow more productive. And there's literally, every time I search for every time we test the bar for AI, and we see this bar just pushing forward. So you could really use AI to solve almost any workflow in software development. So, for example, of course, it's great for generating boilerplate code. It's great for generating testing, data model, schema, documentation, and it's just fantastic for doing refactoring and modernization. The other day, we had to migrate our backend from one framework to another, and something that in the old days would take us probably a month. And with AI agents, we were able to make that change overnight. So my suggestion is that in your next project or in your next task, search for where AI can lift off the cognitive load and the stress from your work. One example that I really like to share is from last week, where we had a very, I call it the boring story of software 3.0. We had an issue coming from a monitoring system, Sentry, and it was really just an AO API AO that we didn't handle. It's nothing special. It's not very complicated to debug and to investigate and to solve, but it takes time. But with AI agents, we could just tell the AI, hey, this is the bug report from Sentry monitoring tool. This is all the context that you need. This is how we want to solve it. And in 5 minutes, before breakfast, the issue was solved. And it's not that it's complicated, right? It's something that senior developer would solve in a few hours. But the specifics are boring. The specifics are, okay, now I need to understand where exactly the issue is coming from, and I need to understand which library I want to use to solve that, and to understand the specific APIs. Now, the solution, the high-level solution, I still, as a human, I provided to the machine, but the machine handled the specifics, the boring part of the job. So this is at least how I use AI in my day-to-day workflow. And just as to wrap up the conversation, so AI is changing completely, it's transforming how we build software. And sooner than later, we're going to focus a lot more on design rather than coding and the specific details of software engineering. We still need to do the last mile. It's becoming less and less significant, but and the more the specs and the design and the context is better, the last mile is shorter, ironically as it sounds. And testing, of course, it's an integral part of this new workflow. And I think that one thing that is important to remember here in this conversation is that we're in a transition period. So AI, it's not magic. It has a huge potential, but it requires to change the mindset. It requires to change the state of mind. It's not that easy to transition to AI workflow in your development, even though the promise is huge. And once you do that, once you do the transition, I think that most people will not go back, because there is so much details left out, and ultimately it brings the ultimate developer experience coming back to the where we started with dark mode. So, but there is a transition. It's like you're being used to developing in C, and you want to transition to high-level programming language like Python. Obviously, once you make the transition, you probably don't gonna go back to build software in C, but it requires a change of mind and transition period, and it requires learning some skills like prompting and writing specifications. But I think that when I look at our journey in Fine, where we build 90% of our code with agents with Fine, I think that's, for me at least, in the last 15 years in software development, that's really worth the change. So I think that's my perspective on software 3.0. And yeah, thank you all for listening, and I'm here if you have any questions.
Fantastic. Thank you, Dan. So guys, thank you for attending. We will now start a Q&A session. You're welcome to ask us anything about software 3.0, future of software development, and anything you want to know about AI agents. Let's go.
I do have a question about, like, how much specifically should we know about operating AI? Will it be a lot like how, like, the equivalent of Spring Boot, how Spring Boot was meant to shorten Java code? Is AI going to essentially be like this under the hood type of machine that we're going to use, or would it be wise to study as much about AI to understand its processes, to tweak the AI as much as we can as a software developer?
Yeah, so it's a good question. I think that yeah, nothing should be a black box, right? The more we understand how AI works, then the result will be better. We need to develop, actually, we need to develop skills. We need to develop communication skills with AI. And if we have a basic understanding of how this LLM works, then we can communicate better with them in a way, if that makes sense.
Yes, thank you.
I just wanted to back up for a sec on the IDE thing. Wouldn't a developer's primary job still be to look at code versus older code that is diffing against version control and committing to code that is considered done? And you do that in IDE now. Maybe you use some other combination of tools. You know, maybe it's more modular, like a text editor and a Git tool that are separate but integrated. But whether or not you call that an IDE, I think is a separate debate. But isn't that still the core workflow?
Yeah, absolutely. I mean, the way I see it, at least, or the way I experience it, is that IDEs, today's IDEs, are focused entirely around code. Like, the main dish is code. The old UX is centralized around the assumption that you, as a human, need to write code and review it all day long. I think that the better AI becomes, then that part is being less and less significant. And I think that interfaces like GitHub pull requests will be more relevant to this assignment. So I mean.
Okay, all right. I'm just trying to clarify that because I think there are some people, mostly not coders, who envision AI being something that writes the code more on its own, and that there would be the review process would be more like a Q&A type of thing, where you just run the thing that it built and see if it does what you want, and if it does, then you use it, and if it doesn't, you tell it to go refine it, but you don't actually even look at the code.
Yeah,
I think what you're envisioning is that we're still coding in the sense that we look at code and we compare code to other code, and and possibly even manipulate that code before committing to it, because it's most of the way there, but we have to take it the rest of the way. So the tool set is still going to be similar. And when you talk about GitHub, GitHub's becoming an IDE. So I'm not trying to be difficult about it. But I do want to clarify that, like, you're in the same camp as other coders who think the AI will be an enhancement for manipulating code, not in lieu of writing code altogether.
I think that it depends on the use case. I can see use cases that where AI takes completely developers away from code. For example, like visual programming. I can definitely see a reality where you build UIs right within Figma, for example. But yeah, I think code is still here, at least for the short term. Just the proportion is changing.
I mean, if I had to make a prediction, I would say that with this current idea of LLMs, because let's be clear, the AI is just like this umbrella term now for a bunch of different stuff, right? And machine learning and LLM are really different things. But we're talking about LLM more specifically right now, right? Like that's the new thing as far as you can generate code with that, as opposed to like stuff a bunch of required outputs into something and then have it machine learn how to get to that. It never generates code. It just, I mean, it generates perhaps some sort of binary, the CPU, but that is a black box in the sense that you can't dissect how it works. You can just either sign off on what it does or not. But with LLMs, you can at least look at the code it generated and decide to use it. The thing that generated that is a black box, though. Like, we don't know how that stuff actually works, right? Like, that's one of the dirty little secrets of these vector databases is that we don't actually know how it's pulling the stuff out of that. We can't even remove something once you put it into the training data. If you just want to excise one little thing, there's no surgical way to do that. So it is a black box, but that's okay. So you have something that generates code, you look at it, you decide whether or not you want to use it. It's still code. You're still being a developer in that sense. But you can if I had to make a prediction, LLMs will be good at generating code that works, but not necessarily good at writing elegant code. So what we'll end up with if we move towards a world of, depending on the speed at which it can push out code as a boon, is that we'll actually have to deal with more code, but in a more superficial way. So you just be like scanning through code, like yeah. It's longer, it's more boilerplate oriented, so it's a little bit more tedious to read, but it's also perhaps less difficult to read because there's nothing fancy going on. The LLM will be better at generating code that is stupid simple, I think is maybe the way to say it. So then you just, it's not necessarily the way that a human would write it, because a human's going to want to not do things that are repetitive and organize the code in a way that is less work to write. Like, in their mind, they're going to solve the problem a little bit more carefully before they start writing. But the LLM can just start. So I think we're actually have to deal with more code. So the IDE will perhaps be a tool that we become even more dependent on, because we have to deal with the type of code that, like Java is well known as a language that requires an IDE. You don't just use VI and write Java. I mean, if you do use VI and you do Java, you probably have so many things added to VI that you've created yourself with IDE. You can't do Java without an IDE. It just, the language is not amenable to that. But so comparing that type of thing to something that's like scripting stuff that is more succinct, I think that we're going to end up more with that Java type of code, regardless of which language the LLM's generating code in, just because that's what it'll be good at, and we'll be able to read it, and we'll be like, yeah, we can sign off on it. And over time, these code bases will bloat because they'll be correct, but they'll be more boilerplate. But we'll have to actually get better at reading diffs and committing, and that will require those tools to actually get more powerful.
I see what you mean. I see what you mean. There's definitely one way, one future route that that programming can take, that software development can take. But one might say, you know, we can open our vision a bit, even like make it even larger, and say that in a future where AI writes most of the code and there's almost no need for us to review it, we might not even go to like extra bloaty code and go to even like more languages like assembly and C#. You know, like why not tell the AI to write only in those languages or only in those non-readable languages if they have better performance, and it's easier for the AI just as much, you know? So there are many future timelines that we can go into. I believe, looking at the advancement that we've already made with LLMs and with coding and with coding assistants and agents, I believe that we will take the more advanced route, and we will go down the road that takes as much off from the developers as we can. And well, but that's my personal belief. I will let a few.
Yeah, I actually agree with you that it's also possible to have it generate code that we wouldn't really want to fathom, you know, generate low-level things like essentially machine language, just generate instructions to the processor, and it could probably come up with performant constructs that would be too gnarly for a human to do by hand. Like a human could do them bit by bit, but the order of magnitude difference in how quickly a human could do it versus the machine would be even greater than like a code language that was designed for humans to read well. But that would be something that is not really just using LLM, but actually using machine learning as well. Like you're basically having the LLM generate stuff, and then you just throw that into something where it trains on whether or not the output is correct. And yeah, it feeds back into the LLM where the LLM can generate something else to try to fix the little bit that's needed. But the goal seeking is driven by a machine learning process that just looks at what the humans have said they want inputs and outputs to be, and they don't even look at the code anymore.
Definitely many aspects will improve, and not only just like the simple input output to the LLMs. Many workflows will improve. They will include many aspects, so that's definitely correct. I'll take a few more questions, so just so we get more questions from the crowd. We can continue this conversation later. I'd love to. So I see David raising their hands.
Yeah, me too. I would love to ask a question.
Yes, I primarily, as a value-added reseller, I customize other people's code. I don't write it from scratch. Can you make any comments about the difference between changing existing code versus writing new code with AI?
Yeah, I think that's the holy grail, right? Maintaining existing code, because using AI to write boilerplate code is nice. It's like a personalized boilerplate code from GitHub that you can download. But the main thing would be if we are able to use AI to refactor and use and maintain existing code, to add features to legacy systems. It's not easy. It's not easy, and of course, the more the code is older, then the harder the task becomes. From our experience, this is why AI agents, like fine-tuned AI agents, are necessary, because you train an AI agent on the specific code base with the specific gotchas of this code base, and then they're doing better job in maintaining it and adding features. And this is why if you have a huge monolith and you can have some part or convert like some parts of the monolith where you can have specific agents that are specialized in those parts, then they will do a better job. So yeah.
So I'm sorry, just to clarify, from what I gather from like the three of what you three said, essentially there will be more automation, but obviously because AI will be taking care of a lot of the simpler code, but it'll be more so design base will be a lot more relevant than the actual coding until we get to specifics that are needed for the client. So like basic things that are in every website will be automated. Then there'll be more specifics that people have to deal with. And of course, our jobs will more be like gatekeepers, just checking if everything works before we give up.
Before we give,
Yeah, I will also add that I think maybe gatekeeping would be one part of our job, but I wouldn't say that it would be the major part. I would say the major part would be designing the solutions and coming up with what we want to do, which is still, you know, we still need to be, still need to learn computer science. We still need to learn how to build robust software systems so that we can make a great design. And following that, we need to make sure that the agent followed our design. So there's a huge chunk over there at the beginning that we want to relate to.
Hey, I have a question. Thank you, Dan, for your talk. So let's assume that all the code from today in the next 10 years will be written only by AI. Okay? This is the future. We are ready for that. So the meaning is that there will be no new frameworks, not new languages. So we'll be stuck. And yeah, I see that you want to answer. Yeah.
No, I think it's the other way around, actually. I think that, well, it's all predictions, right? So don't take me up on my word, but I could see an alternative reality where there will be new frameworks and technologies that are more optimized to AI. If you think of it, the entire stack that we work with today, React, Python, all of those languages are built for one job, one goal is in mind, to make it easy for human developers to maintain code. Right? They are built only for a developer experience, right? Now, JavaScript, vanilla JavaScript is way more efficient than React, right? So I'm not saying that this will be the tomorrow. We will see tomorrow in production vanilla JavaScript across the internet, but it's reasonable to assume that we will have more frameworks that are maybe more difficult for humans to interact with,
but
like the bones, but for the AI, they're easier.
The catch is that you need is that you need data in order to train the machines. So today we already had a lot of code for React. So LLMs can produce React, but it's like it's an oxymoron. Okay, in my opinion, I'm not have deep knowledge about LLMs, but yeah. And
it's like the question. The question is where it's a more broad question. Where does LLM learn from? And I think there are better minds than me to answer that question. And I think that the brightest minds on OpenAI and Google work on ways and develop new techniques to study to teach LLMs new data, and I know that there are a few more approaches, like Jonathan, correct me if I'm wrong, but like reinforcement learning or others. But my assumption is that LLMs will get better and will find a way to teach them new skills and data.
Yeah, I want to add just one thing. LLMs built on statistical models. So statistically, it's really hard to produce low-level languages. To produce if the next char is 0 or 1, it's really, really difficult than high-level languages. So
I know. But look, other programming languages like C are not like C or vanilla JavaScript even. They're not low-level programming, and they are more efficient than most of the.
But not machine, not assembly
not assembly. Yeah.
These are the final 5 minutes or so. So I think we can take a few more questions, if anybody has them.
Regarding your product, what languages is it? Like all languages, all IDE, all frameworks compatible, or are there specifics? Because it's just that I use a specific IDE all the time.
So yes, so we follow this philosophy of bring your own agent. So we actually developed a agent-driven workspace where you can customize the agent to work with your own tech stack. So you can fine-tune the agent to work with Ruby or JavaScript or any other languages or tech stack that you use.
I see a question in the chat. Maybe it's good for you then. Can we talk a bit about Fine's roadmap? And maybe do we plan to use other various LLMs? Maybe a bit about the future of this.
Yeah, so our main focus today, Fine is still very new. Our main focus is to get the agent work, like to do the 85% of the task for you. And we're putting a lot of efforts on giving you tools to guide the AI agents. That includes AI hinting, context sharing, customizing the agent, and taking the last mile within Fine. We also focus on getting on the review process. One feature that we're going to release in a few weeks will be self-review workflow for the agent, where the agent can run a linter or test and then fix the code based on the result. And later, we're going to focus more on privacy and security, which is something we see that is very important for teams. We really want Fine to be the first AI-driven software development environment that made for teams. So we focus a lot on Teams features as well.
I have another question. What differentiates Fine from, let's say, GitHub Copilot?
Yeah, absolutely. So GitHub Copilot is a great assistant. We call them like a pen pal assistant. They are great to help you in the next line, file, function within the IDE, where AI agents is something that works the end-to-end workflow. It is designed to build a feature or to solve a bug, like to take the end-to-end assignment. Like your virtual teammate.
Okay, so you don't see yourself developing plugin for IDE in order to develop a full feature inside the IDE?
Yeah, we work alongside the IDE. Sometimes if it needed to take the last mile, we switch to the IDE, and then there we have the GitHub Copilot, and we can use that as well. But we would like to see it more as your junior developer or mid-level developer, where you delegate the task and you guide them and you make revision with them. It's like when you work with other developers, you don't go to their IDE and start code for them. You give them revisions and comments in plain English on their GitHub pull request. So this is how we design it in mind.
Okay.
All right.
Okay.
So thank you, everybody. Thank you so much for attending today. We had a pleasure hearing your questions and answering, and it was really interesting, and I'm glad that you guys attended. If you want to continue the discussion, feel free. I just sent the links so you can join, and always contact us. We're very available and reachable. And yeah, we are looking forward to hearing from you and maybe to seeing you again in our next webinar.